In this question, we're using the sine rule to find an angle. So we're told about this triangle ABC. It has sides of 4 and 3 and an angle B of 44 degrees. Let's try imagine what this might look like. And we're told there's two possible triangles this might look like. So let's imagine one of them. So we have a side 4 and a side 3, and the angle at B is 44 degrees. So where would the other one of these? Well, if you imagine taking the arm AC, if you take that side, and if you could imagine rotate that inwards a little bit, you could imagine that we could, a side of 3 might fit in here as well. So we have two possible positions for the point or vertex C in our diagram. So these would be the two possible triangles. In the second part of the question, we're asked to find the two possible values for the angle at C. So we're going to use the sine rule to do this. We will see in the sine rule that we're interested in angles and sides that are across or opposite from each other. So we notice that C1 is across from 4 and the angle at B is across from the side of 3. So these are linked up in the following way, like that. We're going to use the version of the sine rule that has the angle part on top. So I'm going to write that sine C over the side across from it, 4, is equal to sine of 44 divided by the side opposite, 3. I'm just going to solve this out. We might notice that C then would be equal to the sine inverse of 4 times sine 44 divided by 3, just by manipulating the formula. So I'm going to sub this into the calculator to evaluate what the angle C is equal to. So I see C works out to be 67.85 degrees. Looking at the diagram, you might notice this is an acute angle. So this must be C1. C2 is an obtuse angle. So we want to find the other angle, C2. What we're interested in here is an angle that the sine of this angle will give us the same answer as the sine of 67.85. So we could draw a little sketch of our 67 angle here on kind of the 4 quadrants. So we have an angle roughly of 67.85. It doesn't have to be exact. We want to know where in the plane would we find another angle with the same sine output of this. So if we think about our cast system, we're interested in where sine is positive. So sine is positive in the first and in the second quadrants. So the angle we're looking for angle must be in here. It must be somehow related to this angle 67.85. So we might guess that it's 67.85 short of the 180 degree angle. So if we take 67.85 from 180 degrees, we see that the angle that is missing is 112.15. So that's probably what the answer is. I'm very confident that is correct, but to be 100% sure, if we just write the sine of this angle, the sine of 112.15, and we see that it gives us the same answer as the sine of 67.85. And by checking it this way, we know that we're definitely correct.